Hi everyone, welcome back to my geometry tutorials. In this video, I like to go over special right triangles. So we've already seen Pythagorean triplets, so there are other types of special right triangles. The sides of a 30-degree, 60-degree, 90-degree triangle are in the ratio of x square root of 3 times x and 2 times x, where x is the length of the shortest side of the triangle. The sides of a 45-degree, 45-degree, 90-degree triangle are in the ratio x square root of 2 times x, where x is the length of the shortest side. So I'm going to prove a lemma here. So remember, a lemma is like a theorem that's used to prove another theorem. So it's like a helper theorem if you want to think of it like that. We're given triangle ABC is equilateral. Let's prove that the measure of angle C equals 60 degrees. So I write down what I know. I know ABC triangle is equilateral, and all angles of an equilateral triangle are congruent. So angle A is congruent to angle B and congruent to angle C. By the definition of angle congruence, measure of angle A equals measure of angle B equals measure of angle C. Now we know, since we're dealing with a triangle, the sum of the measures of the angles of a triangle is 180 degrees. So in other words, measure of angle A plus measure of angle B plus measure of angle C equals 180 degrees. Now what I'm going to do is I'm going to substitute. So I'm going to let measure of angle A equal measure of angle C and measure of angle B equal measure of angle C. If you plug this into the equation we have in statement 4, we get 3 times the measure of angle C equals 180 degrees, and I just divide by 3 to get measure of angle C is equal to 60 degrees. Since all these measure of angle A, measure of angle B, and measure of angle C are all equal, in other words, an equilateral triangle, each angle measures 60 degrees. So let's see how we're going to use this. Given triangle ABC is equilateral, we're given that the length of segment MC equals x, and that triangle AMB is congruent to triangle AMC. Let's derive the 30-degree, 60-degree, 90-degree triangle ratio. Okay, so we write down what we're given, and we can say that since triangle ABC is equilateral, measure of angle C is equal to 60 degrees. We know by corresponding parts of congruent triangles are congruent that angle AMB here and angle AMC here are congruent. And since this is a straight line, these two angles are going to be supplementary, right? So angles that are both supplementary and congruent are right angles. So angle AMB and angle AMC are right angles. A right angle measures 9 degrees, so measure of angle AMC equals 90 degrees. The sum of the measures of the angles of a triangle is 180 degrees. So if we look at this triangle, measure of angle AMC plus the measure of angle C plus the measure of angle MAC is equal to 180. So we're just looking at triangle AMC, right? If I substitute what I have in statement 4 and statement 7 into statement 8 and do some simplification, we get measure of angle MAC is equal to 30 degrees. So that's so we're dealing with a 30, 60, 90 degree triangle here. So we know all sides of an equilateral triangle are congruent. So in other words, segment AB is congruent to segment AC, which is congruent to segment BC, right? And we're talking about triangle ABC in this case. So we know that triangle AMB is congruent to triangle AMC. Therefore, segment MB is congruent to segment MC. And therefore, M is the midpoint of segment BC, right? Because a midpoint divides a segment into two congruent segments. So in other words, the length of MC is equal to 1/2 times the length of BC. So we know that MC is equal to x, right? So BC, if we do some algebra here, we get length of BC is equal to 2 times MC, which is equal to 2 times X. And since by the definition of congruence, right, length of AB equals length of AC equals length of BC. So in other words, if BC equals 2x, then AC is also going to be equal to 2x. So we get this 2x here, and we know that triangle AMC is a right triangle because angle AMC is a right angle, and a triangle for right angle is a right triangle. We can apply the Pythagorean theorem and do some simplification, and then we end up with length of AM is equal to root 3 times x. So then we see this ratio where we have x, root 3 times x, and 2x, and that's the 30, 60, 90 degree triangle ratio. So there's a lot of steps here, so just kind of go over them. I'm very detailed about the steps, so you could definitely condense it and shorten it. Hopefully I don't write too much detail that so that it confuses you. I just want to make sure that if you have any questions, the way to read my notes is just to kind of go over it, and if you have any question like why is segment MB congruent to segment MC, you can always look back and have it fully written out. So with that said, let's go on to the next problem. So we're given that triangle ABC is a right triangle. The measure of angle A is equal to the measure of angle C, which is equal to 45 degrees, and we let BC, the length of BC equal to X. Derive the 45 degree, 90 degree ratio. So I write down what I know, and I know that angle A is congruent to angle C because the measure of angle A equals the measure of angle C. So we know in a triangle, if angles are congruent, then the sides opposite those angles are congruent. So in other words, segment BC is congruent to segment AB. By the definition of segment congruence, we get length of segment BC equals length of segment AB. Could apply the Pythagorean theorem because ABC triangle is right, so you get AB squared plus BC squared equals AC squared. Now I'm going to substitute what I have, BC is equal to X and AB equals BC, so it's also equal to X. And you put that into the Pythagorean theorem, do some simplification, you get AC is equal to the square root of 2 times X. So in other words, we have this, X square root of 2 times X ratio. Let's do some computational examples. Example 1. Given triangle ABC is a 45, 45, 90 degree triangle, angle B is a right angle, and length of AC is equal to 6. Find length of BC. So let BC equal to X. So then since we have a 45, 45, 90 degree triangle, we know that AC is going to be square root of 2 times X. So that square root of 2 times X is equal to 6. So we're just trying to find BC, so that's X. So X is equal to 6 divided by square root of 2. Let's do another example. Given a triangle ABC as a 30, 60, 90 degree triangle, angle B is the right angle, measure of angle C is equal to 60. Length of AB is equal to 5. Find length of BC and length of AC. So we know that angle C is going to be 60 degrees and angle A is going to be 30 degrees. So we're going to have, if BC is the length, then length of AB is going to be square root of 3 times the length of BC, and the length of AC is going to be 2 times the length of BC. So we don't know what BC is, so we have to find that, right? We can just divide by the square root of 3, right? Length of AB divided by square root of 3 is equal to 5 divided by square root of 3. So if BC equals 5 divided by the square root of 3, then square root of 3 times 5 divided by square root of 3 is 5, and you get that AB is equal to 5. So that's the right computation. So AC the length of AC is going to be BC times 2, so 10 over root 3. Okay, now I'm going to do some problems, and I know there's so many steps here, so it's very detailed, so you can definitely, like I said so many times, you can condense a lot of these steps. I write out the steps so that if you have any questions or concerns about, how, I'm reasoning this out, I just go back to the theorems and the postulates we've used. So let's try this first problem. Given segment AC is perpendicular to segment CD, and that segment AC is perpendicular to segment AB, measure of angle D is equal to 60 degrees, and length of segment AC is equal to 3, and length of segment CD is equal to 5. Find the perimeter of ABCD. So write down what we're given, and what I'm going to do is I'm going to draw a segment BM that's parallel to segment AC. So in other words, you can use the parallel line postulate to draw this parallel line through B and parallel to AC and intersect CD at point M. Okay, we know that since segment AC is perpendicular to segment CD and it's perpendicular to segment AB, and we know that segment BM is parallel to segment AC, then segment BM is perpendicular to segment CD and it's also perpendicular to segment AB. And the reason is if one of two parallel segments is perpendicular to a third segment, then the other parallel segment is also perpendicular to the third segment. Okay, with that said, angle A, angle B, angle C, and angle M are right angles, right? Because perpendicular segments meet at right angles. Therefore, ABCM is a rectangle because a quadrilateral with 4 right angles is a rectangle. We know opposite sides in a rectangle are congruent, so segment AC is congruent to segment BM, and therefore by definition of congruence, length of segment AC equals the length of segment BM. We also know that segment AB is congruent to segment CM because opposite sides in a rectangle are congruent, and then you apply the definition of congruence again, length of AB equals length of CM. Now, we know by the betweenness property of segments that length of CM plus length of MD equals length of CD, right? So we can isolate what CM is equal to. It's equal to CD minus MD. Okay, we know that triangle BMD is a 30, 60, 90 degree, right? This is a right angle, so it's 90 degrees, and D is 60, right? So that leaves this angle as 30. So we know that BM, which is opposite the 60 degrees, is going to be equal to the length of MD times square root of 3. But here we're trying to find MD, so we have to divide length of BM divided by square root of 3. We also know that length of BD is equal to 2 times the length of MD, again because it's a 30, 60, 90 degree triangle. So therefore MD is equal to, first I did the MD computation. So if we substitute what we have in 4, AC is equal to 3. What we have in 12, AC is equal to BM, so BM is equal to 3. And what we have in 17, then we get MD is equal to 3 divided by square root of 3 by substitution. And therefore, length of BD is equal to 2 times 3 divided by root 3, or 6 times the square root of 3. So we know side BD is going to be 6 divided by root 3. We still need to know what AB is because we don't know that. So we know that CM is equal to 5 minus 3 divided by root 3, right? Because MD is 3 over root 3, and all of CD is 5, so CM is going to be that. And we know that CM is equal to AB, right? using 14 and the fact this is a rectangle, right? So AB is equal to 5 minus 3 divided by root 3. So the perimeter of ABCD is just you add the lengths together, and remember not to include this BM. I just wrote this to kind of work with this triangle, but we're not interested in this length here. So if you plug what we have and what we solved for, you get 13 plus 3 divided by square root of 3, and that's the perimeter of ABCD. Okay, let's do another problem. So we're given rhombus ABCD. We're given that the measure of angle BAC, this angle here, is 120 degrees, and the perimeter of ABCD is 8. Find the length of BC. So that's one of the diagonals, right? So write down what we know. We know a rhombus has 4 congruent sides, so segment AB is congruent to segment CA, and segment BD is congruent to segment CD. By the definition of segment congruent, the length of AB equals length of AC equals length of BD equals length of CD. And we know that the perimeter of a rhombus is 4 times the length of one side. Well, I mean, technically you would have to, you add all the lengths of the sides together, right? But since these sides are all equal, the lengths are equal in a rhombus, then you just multiply one side by 4, right, to get this. So at any rate, length of AB equals length of AC equals length of BD equals length of CD is equal to 2. 8 divided by 4 is 2, right? So that's where we get that. Okay, we know the diagonals of a rhombus are perpendicular bisectors of each other. So line AD is a perpendicular bisector of segment BC. Therefore, angle AMB and angle AMC are right angles because the perpendicular bisector meets at right angles with the segment it bisects, right? And the measure of a right angle is 90 degrees. So measure of angle AMB equals measure of angle AMC equals 90 degrees. Okay, we know this property of a rhombus, that a rhombus diagonal bisects its vertex angle. So in other words, we're going to get angle BAM is congruent to angle CAM, right? Because this diagonal bisects the larger angle A. And we know we know that each of these angles is going to be, the measure is going to be 1/2 of the full angle. So 1/2 times 120 is 60. So the measure of angle BAM is 60. So we have a 90, 60, and this has to be 30. So if we look at triangle BAM, right, we have a 30, 60, 90 degrees, so we can apply a ratio. So we know that length of AB is equal to 2, right? In a 30, 60, 90 degree triangle, we have ratio x root 3 times x, and the longest side is going to be 2 times x. So we know this whole side is equal to 2. So 2x equals 2 means x is equal to 1. In other words, AM is equal to 1. And BM is equal to square root of 3 times 1, which is square root of 3. And I condensed it, so I didn't write all that out. But you know that length of BM is equal to root 3, square root of 3. By the reflexive property congruent, segment AM is congruent to itself. So we know that triangle BAM is congruent to triangle CAM by side angle side postulate. And therefore, segment BM is congruent to segment CM. So these two segments are congruent, and therefore the lengths are going to be the same. So length of BM equals length of CM equals root 3. So by the betweenness property of segments, we know the length of BC equals length of BM plus the length of MC. And length of MC is equal to length of CM, so we're not going to worry about the ordering so much here. At any rate, we get BC is equal to square root of 3 plus square root of 3, which is equal to 2 times the square root of 3. So that's the length of this diagonal BC, 2 times the square root of 3. So the last problem I'm doing is challenging, so if you want to stop the video here, you can. If you want to look at a harder problem, let's go ahead and tackle it. So we're given segment AB is perpendicular to segment BC. So this is a right angle, right? We're given that measure of angle 1 equals measure of angle 2, which is equal to measure of angle 3. So in other words, each of these angles is going to be what? 30 degrees, right? Because 30 times 3 is 90. We're given the length of AB equals 8 and the length of BC equals 15. We want to find the length of BE right here. So there's a trick to this problem. You have to draw segment EM and then work from there. So let's try it. So I'm going to draw segment EM parallel to segment AB. And we can do that because of the parallel line postulate, right? We can draw a parallel line, hence a segment through E that's parallel to AM, and that intersects at point M, right, with segment BC. And we know that segment EM is perpendicular to segment BC. Why? Because if one of two parallel segments is perpendicular to a third segment, then the other segment is also perpendicular to the third segment. And we know that AB is perpendicular to BC. So since segment EM is parallel to segment AB, then segment EM is perpendicular to segment BC as well. So we know that angle ABC and EMC are congruent because all right angles are congruent, and these are right angles, right? Because perpendicular segments meet at right angles. Now I'm going to use the reflexive property congruence. Angle C is congruent to itself, and therefore we can apply the angle-angle theorem for similar triangles using 8 and 9, these two statements. So we get triangle CME is similar to triangle CBA. So we know in similar triangles the lengths of corresponding sides are proportional. So we get length of CM divided by length of CB equals length of segment ME divided by length of segment BA. So we can substitute, we know that length of AB is equal to 8, and we know length of BC equals 15, so it doesn't really matter which way. Length of CB is going to be the same as length of BC, and the same thing for BA, right? So anyway, if I substitute, I get length of CM is equal to 15 divided by 8 times the length of segment ME. Now, I already said, at the beginning, all of these angles add up to 90 degrees, right? So measure of angle 3 is going to be equal to 30, right? Well, this is 30 degrees, and this is 90 degrees, right? So in other words, we're dealing with a 30, 60, 90 degree triangle in triangle BME, right? So at this point, I'm going to use the betweenness property of segments. CM, length of CM plus length of MB is equal to the length of segment CB. So what is length of MB going to be equal to? Well, we know the length of this whole segment is 15, right? And we know the length of CM is equal to 15 over 8 times the length of ME. So I just substitute, and I get MB is equal to 15 minus 15 divided by 8 times the length of ME. So we also know, since this is a 30, 60, 90, well, the length of ME times root 3 is going to give you the length of BM, right? Or MB, whichever way you want to take it. So if I set these two things equal, and then I use some algebra, we find length of ME is equal to 15 divided by square root of 3 plus 15 over 8. And we know then that the length of BE is equal to 2 times the length of ME, which is 2 times this thing, this quantity, so it's equal to 30 divided by square root of 3 plus 15 over 8. This was a tricky problem. It's good to look at, good to go over. And I want to thank you for watching my tutorials, and I hope to see you, during my next video. All right, take care, everyone. Bye.